Going through a couple of examples of direct proof. Direct proof is one of the easiest proofs you could complete because it just wants you to use your algebra skills just to prove that one side is equal to another. So quite direct. So for example, if I want to prove that this side is equal to the other side, now you can have a choice of which one you freeze and which one you'd move, and you should get to the same conclusion. So for example, if I want to show that the left hand side leads to the right hand side, I'm just going to freeze this and just keep it the same, and I'm going to play around with this one. Now it could also work that you could expand this, play around with it to get to this part, up to you. Sometimes picking one would be easier than the other, so make a smart choice with that. So I'm going to freeze this side, and I'm going to try and prove that a plus b squared and plus a minus b squared is equal to this. So the first step is to expand. So expanding each one would give me, so this is a perfect square, and I'm going to get a squared minus 2ab plus b squared. Now I'm not going to write equal to this side because this is what I want to get to. And I can simplify this. I'm going to collect the like terms. So these will be collected, this will be collected, but if you notice, these will cancel out. So I end up with a 2a squared plus 2b squared. And again, using algebra skills, you can notice that this can be factorized. And that's it. That's the end of the proof. Now you could either write QED or colored box. That's another way of ending a proof, but we'll make sure that you've ended your proof at some point. And that's it. We've proved that they're equal. So the idea of direct proof is, the idea of any proof actually, is to be able to use all the algebra skills that you've learned so far. Another typical type of proof they would ask you is dealing with numbers. So we want to show that the product of two odd numbers is always an odd number. In here, the setup is really important, and as soon as you learn how to set this type of question up, you'll be using the same setup for every other question. So for example, if I say I need two odd numbers, so I want to define two odd numbers. Say these are my two odd numbers, but I want to really show you that they're odd, not just tell you that they're odd. So m is an odd number. It could be 2k plus 1, where k is an integer. So the idea of this is that, keep in mind that odd numbers are always either plus or minus an even number. So if I'm talking about 6, for example, an odd number will always be 1 more or 1 less than an even number. And we have the perfect way to describe even numbers, and it's by saying that it's 2 times something, and this something could be any number. In this case, the something is 3. So if I add 1 to it, I'm going to get a 7. If I subtract 1, I'm going to get a 5. So that's the idea. If you want to define even numbers, you're going to use 2k, for example. Now, it doesn't matter if I'm using plus 1 or minus 1. It would work with both. I would recommend you try with minus 1 as well to make sure that the proof works. Now, it's two odd numbers, which means this is a different odd number, and it's not necessarily next to it. So I can't do 2k minus 1, for example, because they didn't tell me they are consecutive odd numbers. If they did, then this is what you do. If they told me you could do 2k minus 1, you could do 2k plus 3. So that will be the next odd number. But if they didn't ask you for a consecutive one, you have to pick a different letter for this. So I could pick J. Any letter would work. Any letter other than M and N. So J could be any other integer, any other odd number. It could be the same odd number. J could be any other integer. It could be the same integer as K, or a different one, or the one next to it. It doesn't matter. But it is a general other one. It could be the same, it could be different, but I'm leaving my options open, which is why I'm using a different letter. So just the long explanation of this setup is important for other examples that are similar to this. So I want to see that the product of them is always an odd number, so let me multiply them. So I'm going to go mn is 2k plus 1 and 2j plus 1. Multiplying this out will give me 4kj plus 2k plus 2j. And if you notice, again, we're going to use our, and then the +1 in the end. We're going to use our skill of factorizing, so I can factor 2 out. This will be 2kj plus k plus j plus 1. Now, if you notice, this is basically the same setup as before for setting up an odd number. So this will be your even number, and then an even number plus 1 would give you an odd number. So this whole thing is even and then +1, so it's going to be an odd number. Another way to just clearly show this, if you want to, well, because k and j are integers and you're just multiplying by integers, so you're going to get an integer times 2, another integer plus k, another integer plus j, another integer. So this whole mess is also another integer, and I could call it s. So this is another integer, which means I can rewrite this as 2s plus 1, which again is the setup for an odd number. So we could say hence an odd number, and that's it. You've proved it. So QED. So that's the idea of direct proof. What about if you have shapes in there? So something that wouldn't exactly tell you what to do precisely. So this question, the diagram here shows a trapezium ABCD that has been divided into 3 triangles. Use your knowledge of areas and the diagram to show the Pythagoras theorem. So we need knowledge of areas. We have a clue here about using the trapezium, and we can't use the Pythagoras theorem. Be very careful about this detail in terms of proofs. You can't use the result in order to prove your result. You need to get to this conclusion. Now, looking at this question might not seem very clear what you're meant to be doing. But this is where practicing proofs comes into hand, where you have to practice a couple of proofs just to know which route you have to take. You also need to take as many routes as possible. You'll arrive at a dead end, but one route will at least work. So let me see. They've told me to use the areas of knowledge of my area. Well, I know the area of right angle triangles. I have 3 right angle triangles. I also know the area of a trapezium. So if I redraw this as a trapezium only, I have my 2 parallel sides and I have my height here. So let me see. The area of my trapezium, so ABCD, will be the top part plus the bottom length, so A plus B, divided by 2, and it's going to be multiplied by the height, the perpendicular height, which is B plus A. This whole thing is just the length A plus B, because this is B and this is A. So this is multiplied by A plus B. Now, just in terms of simplifying fractions, this is A plus B times A plus B, and then 2 times 1. So this is basically A plus B squared over 2. Now, if I have the area of the trapezium, well, I can also find the area of each triangle. And this will be half times, well, I have the base here, I have the height here, so perpendicular height, so this is half AB. This is also half, I have the base, I have the perpendicular height, so again, half AB. And again, this will be my base, and this will be my perpendicular height, so this is half C squared, so it's just C times C. So actually, the area of the trapezium, which is all of this, is the same as adding up all the areas of the triangles. And to simplify it, I'm going to get AB. So half AB plus half AB is just AB. And this is half C squared. And again, as I mentioned, it's just a matter of using your algebra skills. So I'm going to multiply both sides by 2 just to get rid of this 2. But remember, you multiply the whole thing by 2. So these 2 will cancel out, so I end up with A plus B squared. This 2 will cancel out with this, the denominator 2, but then it's going to multiply with AB, so 2AB there. Again, brush up on your algebra skills if this is not clear. I'm going to take this to the other side, so I'm going to have minus 2ab equals to c squared. If you expand this, you're going to get a squared plus 2ab plus b squared minus 2ab equals to c squared. And hopefully you've noticed that these two cancel out, and you end up with a squared plus b squared equals to c squared. And that is precisely what we wanted to prove here. So take the hint from the questions, use the ideas that you know, formulas that you know. It's just a matter of using algebra. So these are the ideas of direct proof. Other videos show different proofs, so have a look at those.